Forces Final iMovie by Derek Halloran. I'm going to talk about different forces in physics. Examples are energy, power, intensity, and strength. My first slide shows how forces affect an object, in this case a plane. This force is measured in SI units in newtons. In this case, all kinds of forces are demonstrated on the plane, such as lift, thrust, drag, and weight. Forces cause objects to move, fall, expand, and contract. The more mass an object has, the harder it is to move, stop, change the speed or direction of the object. An object will not start, not stop moving, not change speed, and not change direction unless a force acts on it. SI units are fundamental units and derived units. Fundamental units cannot be broken down into a different form. Derived units are made using fundamental units, and below are some examples. Fundamental forces are the ways that elementary particles interact with one another. All are non-contact forces. The four forces are strong, weak, electromagnetic, and gravity. Also to note is that gravity, even though it's the weakest, as everybody sees it, they would think that gravity is the strongest, since it holds all planets together and makes sure that we don't go floating off into space. But believe it or not, it is the weakest, even though most people, again, think that it's the strongest. The four fundamental forces in order of strength are strong, electromagnetic, weak, and gravity. Examples of strong is a nuclear fission, electromagnetic, a lightning strike, weak would be a balloon, two balloons repelling each other, gravity could be a metronome, or the Earth. Also, the ranges and carriers are listed, even though we do not know yet what gravity's carrier is. In this is a contact force, and if you don't know what that is, it's basically whenever two objects touch each other and affect each other. Like in this car crash, you can see the two cars affected each other with touching them. And that is what the definition for contact forces are, any two objects that affect each other by touch. Next is non-contact force. It is when a force does not touch the object, but still affects it. Watch my video to see wind resistance and gravity affecting the ball. These are the types of forces, and the first parts are the abbreviations of each. First is tension. That is when tension is transmitted through something, like a rope or anything, and it is equal and opposite. You could say it's balanced. My example is of tug-of-war, and as you can see, the two people stay in the same position because they are pulling at an equal force. The next force is normal force. A normal force is a component that is perpendicular to the surface of contact. My slide shows what it means to be perpendicular. My next slide is an applied force. And the definition for this is when a surface or body force is acting on an object. I chose a guy pushing a crate because it's a great example. Basically, it's showing the body force pushing the object. And that is what an applied force is. Now on to gravity. Gravity is the force of attraction between all masses in the universe. Here, the Earth is pulling the meteor to our atmosphere. Since the Earth's gravity is stronger than the object, we are pulling it to us. But if the gravity of the other object was more than ours, it would be pulling us, and we would probably be doomed, depending on how it is. Let's not forget about friction. The force exerted by a surface as an object moves across it. The object is moving one way and the friction is moving the other way. And the friction is already under the box where it's touching. Another good example would be dragging your feet across the floor to get an electric shock to shock whoever is closest to you. Lastly, we have spring force. No, not the season. This spring is the force exerted by a compressed or stretched spring upon any object. Obviously, my slide is of a spring. Think of a screen door opening and closing. Also, a Super Ball is a good example of spring and contact force. I also learned while researching this video that air resistance is also its own force, and since this is a bonus force, I'm hoping to get bonus points. Next is static equilibrium. It is when force is acting upon an object that is at rest or not moving, and the net force is 0 newtons. Also, in my little diagram, mine is showing tension and gravity affecting the bucket. My slide includes an example of a force diagram, which shows equal force, so that's why it's not moving. Next is dynamic equilibrium. The rates of the forward and reverse reactions are equal. The system is dynamic because individual molecules react continuously. By definition, this balanced state of constant change is achieved with the gravity and friction acting on the car. I also added a force diagram, as you can see. Let's talk about disequilibrium. Disequilibrium is a loss or lack of stability and balance due to an unstable situation. My slide has a force diagram showing the North Pole and the South Pole having unequal forces. To better explain the motion of unequal gravity and air resistance, we are going to be watching a skydiver, if you could call it that, falling. At some point, they float, but just for like a second or so, whenever it's equal. Now, this is my video, and it's strange. Funniest stuff I've ever seen. Should I stop? Now on to mass, weight, and force. Mass is the amount of matter in the object. Weight is the gravity on the object. And force is, well, an influence that causes the object to undergo a change, movement, direction, or construction. And mass and weight are mathematically related. For example, the guy jumping out of the helicopter, it shows at different weights how fast he falls. It may not be as entertaining as the cats, but still. This is how location, distance, and gravity are related, and it is called location dependency. For example, number 4, two objects of the same mass can weigh differently if they are located in different locations. Like, I weigh less on the moon than I weigh on the Earth or Pluto or wherever planet you may dump. Okay, so on my iMovie, I am, on the slide particularly, I am going to be using this mushroom right here, as you can see. Very light. Kind of not dense. Very light. It's squishy. squeeze it and break it, and this egg. You can see, normal egg, nothing much. If you probably drop it, it will break. Blah, blah, blah. We are going to be dropping this with this. And as most people would probably guess, the egg would drop first. But they're probably going to drop at the exact same time, hitting the ground exactly at the same time. But who knows? Forces sometimes have a weird way of doing things, but as I could guess, they would hit the ground at the exact same time. Okay, and at the end of the slide, you will see these two drop. Okay, so this is the effect on mass. Mass and gravity basically pull an object down at the same rate, heavy or not. So if they're like small or big, they'll both probably fall at the same rate if they're being affected by the same thing. And both should probably touch the ground at the exact same time, seeing on how it is. Sometimes, like say, if you do a feather against a crumpled up piece of paper against a normal paper, it will probably not hit the ground at the same time because of the different effects on it. But most of the times, the effect on gravity of mass on a falling object should be the same. And now to the falling of a mushroom and an egg. Okay, as you can see, we have the egg over here and the mushroom. And we are going to drop them off of the roof. Well, not the roof, the porch. And unfortunately, we have gotten about 0 good times that you can hear me, so we're doing it up front, and then she's going to go down there to tape it. And hopefully it works this time, because this is attempt 5. And again, this will be a good show of gravity on falling objects. And as you could guess, both objects should hopefully land and hit the ground at the exact same time. Like, don't think that the egg or the mushroom will fall first, because they both should fall at the exact same time, unless one misses the table. Other than that, there's no way. Now, wait for my mom to get down there so she can record it. And I'm gonna have to shout now. Okay, I'm just gonna do this part really fast. 3, 2, 1. And as you can see, the egg broke pretty bad, and so did the mushroom. And as you can see, that's what happens. And this is a great example, as I said before, on gravity on falling objects. It looked pretty painful on the mushroom and egg side. And hopefully we're just going to let the birds and stuff do the cleanup. And that is that. As I just showed of a mushroom and an egg dropping at the exact same time, you may be wondering why a feather in a rock does not fall at the same time, and it is because mass and air resistance. Because gravity is stronger due to more mass, since a rock has more mass, and it also has a lot less air resistance. Newton's law. And if you do not know who Newton was, he was a very smart dude, and why we know about gravity. He proved that any two bodies attract each other with a force directly proportional to each other. So think of the Earth. The closer an object gets, the stronger the gravitational pull is. But if the object is far away, it moves slower, but speeds up as it enters our atmosphere. In my earlier example of the Earth, I'm going to use M1 as Earth and M2 as the Moon. And the Earth is bigger than the Moon. And in Newton's law, this force of gravitational attraction is directly dependent upon the masses of both objects. This explains why the gravitational pull of the Earth is bigger than the Moon's. Gravity is also affected by distance. Say if the Earth drifted away from the Moon, another planet would use its gravitational pull and pull the Moon to it, and then the Moon would orbit it. Also, to note, if the Moon got bigger than us, we would start orbiting it. And this shows that gravitation is universal. This movie had a lot of information, but basically everything you touch, see, or do is affected by forces. Hope you enjoyed my movie. Let the force be with you.